Students, welcome back to the physics class. So we have started your first chapters, that is a conservation law. In your previous class, we discussed regarding law of conservation of linear momentum, how that linear momentum is conserved in case of single particle, a system consisting of two particles or a number of particles. Okay. Next, we have discussed regarding center of mass as well as position vector of that particles or center of mass of that system. RCM is equal to M1 R1 plus M2 R2 divided by M1 plus M2. So that the expressions we obtained in our previous class. And the same thing, VCM, that's velocity of center of mass, and acceleration, all those things we discussed in our previous class. Okay. Today in this session, so we will discuss regarding laboratory frame as well as center of mass of frames and concept of elastic and inelastic polymers. Here, what is frame of reference? What it is? What is the frame of reference? So we know that whenever we want to study the motion of the object, what it is? To study the motion of the object, we need to fix the position of that object in order to measure the quantities. Okay. So here, when we study, what I have said is, when we study the motion of the object, we study the relative motion of the object with respect to some arbitrary chosen object. Okay, whenever we want to study the motion of any object, so we are studying the relative motion of that object with respect to some arbitrary chosen object. For that, we are considering some reference point. With that reference point, so we are measuring the variable quantities of that moving object. Okay. So here, the absolute motion of a body is meaningless concept. That already we know that. While the motion related to some other object are having a certain significance. That's why. So we are studying the object with respect to the some arbitrary given fixed point. Okay. To fix the position of the moving object related to the chosen object of reference point, for that purpose, so it is convenient to have a coordinate system fixed to the reference object. What I've said is, whenever you want to study the motion of any object with respect to the some arbitrary chosen point, for that purpose, we are considering what it is a coordinate system. That coordinate system is fixed to the reference object. Such a coordinate system is called as frames of reference. In general, a system of coordinates in space. So what it is? A system of coordinates in space which defines the position of particle or object is called as frames of reference. Whenever we want to study the motion of any object, so in order to describe, so what is the position of that particle, that object in that space, for that we are fixing the certain coordinate system fixed to the some reference quantities. So for that That coordinate systems we are calling it as a what it is frames of reference. Okay, so in general, normally we are defining that frames of reference is nothing but a system of coordinates which defines what the position of the object or the particle is called as what it is frames of reference. A coordinate system in space which defines the position of the object or the particles is called as frames of reference. So things whatever the particle, whatever the your particle is there in space, for that we are mentioning certain coordinate system. So those coordinate systems will give us a complete information regarding the what position of that object. So those coordinate systems we are calling the what is frames of reference. Okay. So normally we are having three types of coordinate systems. Okay. So what are those? So first system of coordinate is Cartesian system of coordinates. The second one is we are having cylindrical coordinate system. The third one is you are having what is a spherical coordinate system. Okay. So these are the types of coordinate systems which are used to specify or describe the motion of the object. Okay. So the simplest type of coordinate system is a Cartesian coordinate system. Where the whatever we are using, that's x, y, and z coordinates are nothing but our what a Cartesian coordinate systems. Okay. So there are two types of frames of reference. So frames of reference is one fixed reference point. With respect to that point, so we are measuring the some variable quantity. Okay. So here, what I have said is you are having two types of frames of reference. One is inertial frame of reference, and another one is non-inertial frame of reference. Okay. So inertial frame of reference is the one in which Newton's laws of motions are forceful. What it is? Newton's laws of motion are forceful. Okay. Uh, Newton's laws of motions are forceful. So in this case, an object at rest continues to be at rest. An object in motion continues to be what? In motion. An object at rest, what it is? Continues to be at rest. An object in motion continues to move at a constant velocity since no force acts on it. Such frame of reference are called as what it is? Inertial frame of reference. Okay. Next frame of reference is nothing but your what? Non-inertial frame of reference. Okay. Non-inertial frame of references. In this case, a frame of reference in which the Newton's laws of motion are not valid is called as non-inertial frame. So all the accelerated frames are non-inertial frames of reference. So here that I have discussed regarding your what it is laboratory frame of reference. So laboratory frame of reference is nothing but in what? Inertial frame of reference. Okay. So there, whatever the Newton's laws of motions are there, they hold true. Okay. Next, you are having center of mass frame of reference. Center of mass frame of reference is one in which already I have defined in my previous class the entire mass of that system remains what it is a constant, remains not constant, or it is the point at which the entire mass of the object is concentrated is called as what? Center of mass of frame of reference. Okay. Here, so see here, for the explanation for your laboratory frame of reference. So I have shown the two pictures, two coordinate system O1 and O2. These are two persons. So measuring and what? Some variable quantity. The red is some object. So they are fixing a coordinate with respect to this reference point. Whatever the coordinate systems they are fixing with respect to this frame as well as this frame. So those coordinate will system the will define what the position of the object is. So that is nothing but what laboratory frame of reference, or it is called it by what it is. Simply frames of reference, but here it is this one is inertial frame of reference. Okay. So how? So these two persons are situated. One person is situated at the point O1, and another person is situated at the point of what O2. So these two persons will what measuring some variable quantity, something, some events which is happening at this point. Okay. Uh, so those things will, whatever the coordinate systems they specify for this object will give you the entire information regarding the motion of that object. Okay. So this is something regarding and what frames of reference. So what I have said is a laboratory frame is the one in which your Newton's laws of motions are holds to. That means the object at rest continues to be at rest. An object in motion continues to be at what? A motion, since no external force acting on that system. Okay. So next one is the center of mass frame of references. Center of mass frame of references. So here, you see the pictures that I'm showing here. In case of center of mass of the system, uh, the we are considering at one point, the point at which the entire mass of that system is what it is concentrated to that point we are calling it what center of mass, and that one, so we are considering it as a what frame. From that point we are measuring the some variable quantity. That's why that is called it as what center of mass frame of reference. Okay. So here, how to say that the center of mass frame of reference is, if the inertial frame of reference is fixed, inertial frame of what is, so let's say it is I, as we say, is nothing but our what inertial frame of reference is fixed with the what center of mass. So here the center of mass of the system. Here the system consisting of an what n number of particles. So here m1 and m2 and m4. So these are the particles existing inside it for what a system. Okay. So what I'm saying is, if the inertial frame of reference is what fixed, is what it is fixed. So what I'm saying is, so this is the inertial frame of reference is what fixed with the what center of mass of the isolated system, and relative to this frame, relate to this relative to this your inertial frame, the center of mass, this one, the center of mass is at what it is at rest. So when it is at rest, the center of mass is at rest with respect to this your what it is inertial frame, then the velocity of center of mass of that isolated system is what is zero. When Vcm is equals to zero, then you are having what Pcm is equals to what P of Cm, that linear momentum of that system means what equals to what is zero. Okay. So this frame of reference is called as what? The center of mass frame of reference. Okay. Therefore, so we can conclude that the center of mass of an isolated system, this center of mass of an what? Isolated system moves with a constant velocity in any inertial frame of reference. Whenever if this reference point is moving, this is the velocity of center of mass is moves with a constant velocity in any inertial frame of what is uh, references. Okay. Next point is in the center of mass frame of reference, the velocity of center of mass is always zero. So what I am saying is in the center of mass frame of reference, the velocity of center of mass is zero. So that VCM is equal to what is zero. So the total momentum of the system of a particle in the absence of an external force in the center of mass frame of reference is always zero. What it is, whatever already I mentioned in the above uh, uh, that so when VCM is equal to zero, that VCM is equal to zero. This already I have told in earlier in the beginning of this defining the center of mass frame of reference. Okay, so see here, so PCM becomes what is zero. So so once again I will clarify you regarding the center of mass frame of reference. If the inertial frame, so whatever that ijk is there, is the inertial frame of reference fixed with the what? Center of mass of the isolated system. And relative to this frame, relative to this your inertial frame, the center of mass is at what is rest. Okay. When this center of mass is rest with respect to this inertial frame, then the velocity of center of mass is zero. When you are having VCM is to zero, automatically the PCM, the total momentum of the system of this accurate system is worth zero in the absence of an what? External force. Okay. This is something regarding your what? Center of mass, frame of reference, as well as what is laboratory frame of reference. So it is these two pictures indicates the laboratory frame of reference. So with respect to these two, this is also laboratory frame, this is also inertial frame. With respect to this frame, so one event is going on, that the red spot indicates and what something is going on here. So in order to describe the event which is taking place as a red spot, so they are, these two persons specified certain coordinates. So those coordinates will what gives the complete information regarding that object. So these two frames are nothing but an what laboratory frame of reference. Okay. Next, this is regarding a center of mass frame of references. Okay. Uh, in this class, another important concept is collision problems. So you know that we know that we are having two types of collision. There is elastic as well as what another one is inelastic collision. Okay. When do the two or what it is particles are collides, a collision is said to take place when two particles interact with each other. During interaction, they undergo a change in momentum, change in momentum and kinetic energy of those two particles. What it is? Collision is a process. This is taking place when two particles interact with each other. Okay. During interaction, there may be a what change in momentum as well as what kinetic energy. Okay, so there are two types of collisions. One is elastic collisions, the second one is inelastic collisions. Okay, so let us discuss one by one. What is elastic collision? A collision, the collision process is said to be elastic if the total kinetic energy of all the particles, what it is, the collision process is said to be elastic if the total kinetic energy of all the particles before collision is equals to what? After collision. Or simply you can call it as the collision process is said to be elastic if the kinetic energy is what is conserved. So such collisions, the collision in which your kinetic energy is conserved, so those collision processes are called as what? Elastic collisions. The example for elastic collisions are the collision between atoms and molecules. Next, the collision between the microparticles and the nucleus, and the collision between two what smooth billiard balls. So these are some of the examples of elastic collisions. In such collisions, in such a process, the internal structure, the nature of the particle does not change. Okay, so those collision processes are called as elastic collisions. Okay, next, let's come to inelastic collisions. In the previous collision process, a collision process is said to be elastic if the kinetic energy is conserved. So here, a collision process is said to be inelastic if the kinetic energy is not conserved, but the total momentum is conserved in both the collision processes, in elastic as well as what? Inelastic collisions. So in elastic collisions, the forces involved are conservative forces, whereas in case of inelastic collisions, uh, it is what? Non-conservative forces. Okay. The example for the inelastic collision is collision between a photon and the electron, and a bullet hitting a target. What it is? Bullet hitting a target. And a car hitting a bike. So whatever the collision process that occurs in nature, so they are nothing but an what? They were inelastic collisions. So due to inelastic collisions, the collision in the definition itself, the kinetic energy is what? Are not conserved. That means that does not remain constant. So whatever the total kinetic energy of all the particles before collision is there, that is not equal to what? Total kinetic energy of all those particles after collision. Okay. This is a brief discussion regarding what a collision processes. Okay. Next, let us discuss how the collision is taking place in case of your elastic collisions. Elastic collisions. Elastic collisions. After colliding, what are the final velocities of those two particles? So that we have to what? Discuss in case of what? Laboratory frame of reference. So we have to take the inner cell frame with respect to that frame. So we have to calculate the what? What are the final velocity of those two particles after collision in case of the what? Elastic collisions. Okay. So see here, uh, the figure in this picture, let your what? M1, we consider one system. consider two particles. Here that first particle m1, the first particle having mass m1 moves with the velocity of what? u1. Whereas the second particle m2 is at what? At rest. So this is the what? The process is taking place in our what? Elastic collisions, where it is in the inertial frame of reference. Okay. When this m1, the particle of mass m1, moves with a velocity u1, is collides with your what? A second particle m2 is at what? At rest. After colliding, what is happening? After collision, the first particle, this is m1, making an angle of what it is? Phi, with its what? Initial directions. It moves in this direction. Okay. Whereas the second particles moves in downward directions by making an angle of what? Alpha. It's what? Initial directions. So here the v1 is the velocity of your first particles after collisions, and v2 is the what? The velocity of your what? Second particles after collisions. Okay. So these two makes a certain angle with what? Direction of your initial one. Okay. Now let us write according to the principle of conservation of linear momentum. Now you have to apply the law of conservation of linear momentum to this processes, because so you have to resolve v1 and v2 into two components. One is along x-axis and one more is along what it is? Y-axis. When you resolve this one and apply the law of conservation of linear momentum to that system, along x-axis our the statement of linear momentum, the total momentum of those two particles before collision is equal to what? After collision. Here, that first particle is moving with a certain velocity, that is u1. The second particle is rest. That's why the momentum before collision is equal to what? m1 v1. That's equals to m1 v1 cos phi plus of what? m2 v2 cos of alpha. Okay, let's say this one is what? Equation number 1. Okay. This is the what? The component of momentum of the first particles along x-axis, whereas the m2 v2 cos of alpha is the what? The component of momentum of the what? Second particles along x-axis. Okay. So along y-axis, so initially those two particles are not moving within along in a y directions. That's why it becomes what is zero. The component of momentum before collision is what is zero. That's why after collision only you are getting what? m1 v1 sine phi plus of what? m2 v2 sine of alpha. This is the what? The momentum of the sum momentum of these two particles after collision. Okay. Next, if the collision is elastic, if the collision is what? Elastic, what is the total kinetic energy of that system is conserved. The collision process is what? If it is elastic, then its kinetic energy is conserved. Before the kinetic energy of those two particles before collision is equal to what? The kinetic energy of those two particles after collision. That's why it is given the what? 1 by 2 m1 u1 square. This is the what? Initial kinetic energy of the first particle. Whereas the second particle is at rest. That's why you don't get it. Only you are getting what? This quantity. This should be equal to what? 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. So this is the kinetic energy of those two particles after a collision. Okay. Next, if let's take the conditions. If m1 equals to m2, that's equals to m, then the equation 1 becomes whatever that the component of momentum along x-axis is there, that becomes u1 v1. That's because m get cancelled. So we are getting u1 equal to v1 cos of phi plus of what is v2 cos of alpha. Okay. Next, similarly, that's your y-axis. Is what it is u1 v1 cos phi is equal to what it is. You take this to this side, u1 minus of v1 cos phi equals to what is v2 cos of alpha x. And next, the second equations, that's your what, y-axis, the component of momentum along y-axis, that also becomes what, v1 sine phi minus of what is v2 sine of alpha, that is equal to 0x. Okay. Next, your v1 sine phi is equals to this one. v1 sine phi is equals to what, v2 sine of alpha. Okay, so let's say this one is what, equation number 5. Next one is your conservation energy, that's total kinetic energy, the third equation. So with the help of that equations, so you are getting u1 square is equal to v1 square plus of what, v2 square. That means so that half m get cancels. Only you are getting what, u1 square, v1 square plus of what, v2 square. This is obtained from what, question number third. Okay. This one you can put it like this. So v2 square is equal to v1 square minus of what is v2 square. I think this becomes wrong. This is what it is. v2 square is equals to v1 square minus of v2 square. Okay, so here this v2 square is equals, this one becomes what it is. So this v2 square is equals to what it is. Here it becomes u1 square. So instead of this u1 square, it should become what? U1 square minus of what? This you take into this side, it becomes what? It is what? U1 square minus of what? V1 square. So some mistake will happen and while typing it. So it v2 square is equal to what? U1 square minus of what is it's v1 square. V2 square v2 square is equals to, if we want this one, v2 square is equals to, it becomes, you take this one to the left hand side, it becomes what, u1 square minus of what is v1 square. Okay, so there is a correction, we have to do it. Next, subtracting equations 4 and 5 and adding, so we get it when you subtract equation 4 and 5 and adding, so we get u1 square plus v1 square minus of 2 u1 v1 cos of phi equals what it is, v2 square equals to what it is. By getting what, v2 square. This, how you are getting this one, squaring equation 4 and 5 and add it and rearrange that equations. So you will get u1 square plus of what is v1 square minus of 2 u1 v1 cos phi is equal to v2 square. Okay. Next, from equation 6, where it is from this equations, that is your what, v2 square is equals to, it becomes what is u1 square minus of what is v1 square is there. So that by using this equation, this becomes what is, so here what I have written here, I want the value of what it is, u1 square. So here that u1 square is there, u1 square is equals to v1 square plus of what is v2 square is there. Okay, so that you have to insert here, so v1 square plus of what is v1 square. When you are substituting, that's is what, u1 square is equals to v1 square plus v2 square. So there you are getting u1 square get cancelled. The remaining thing is u1 square plus of what is v1 square minus of, we are having what is 2v1 2 u1 v1 cos of theta plus is equal to the value of your v2 square. There is what, u1 v1 square. So here I have corrected it, but in the previous case that becomes mistake. Okay, so it is right here. Now v1 is equal to u1 cos phi, that you want to what, say the equation number 7. Okay, next to equation 6, substitute this value in your what, equation number 6. So you will get, and what after substituting this value, so you will get v2 is equal to u1 sine of phi. Okay. So like that, we are getting in what the final velocity of those two particles after collision. See in case of what elastic collision in the what it is laboratory frame of the. Okay. Thank you. So we'll discuss the remaining thing in the next class.